Welcome to the Real Python Podcast. This is episode 112. What do you do when your data science project doesn't fit within your computer's memory? One solution is to distribute it across multiple worker machines. This week on the show, Guido Imperiale from Coiled talks about Dask and managing large data science projects through distributed computing. We talk about projects where an orchestration system like Dask will help. Dask is designed to take advantage of parallel computing, spreading the work and data across multiple machines. And many of the familiar techniques for working with pandas and NumPy data are supported with Dask equivalents. We also discuss the differences between managed and unmanaged memory. Guido shares advice on how to tackle memory issues while working with Dask. This week, we also talk briefly with Jodie Burchell, who will be a guest host on upcoming episodes. As a data scientist, Jodie will be bringing new topics, projects, and discussions to the show. A quick update on the Kickstarter book project by Sherry Eskenes, mentioned in episode 78. Learn Python through nursery rhymes and fairy tales is now available for purchase on Amazon. Link in the show notes. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hi, Guido. Welcome to the show.
Hi. How are you?
Good. I was just asking you offline before we started if you had gone to PyCon, and you mentioned that you had gone to PyCon, is it DE or?
Whatever you want. The one in Berlin, yeah.
Yeah, the one that was in Berlin?
It was great.
Oh, cool.
Mm-hmm.
Did you do a talk or anything there?
Yes, I gave a talk about Dask memory management.
Oh, cool. That's something that we're going to kind of dive into maybe near the end of the conversation today, but I wanted to get a little background on you, and I think a lot of people might not be entirely familiar with Dask. I've seen the name and I've seen it kind of thrown around in the community, especially in the data science community. But I thought we could talk about, what it is as a tool and maybe how someone can get going with it. And then we can kind of dive into some of the nitty-gritty of the stuff that you work on. But maybe we can start here. How are you involved with the Dask project yourself?
I am a maintainer of Dask. I work for Coiled. Coiled is a company that sells a Coiled package, which lets you deploy Dask on the cloud in a matter of minutes instead of you having to go through Kubernetes yourself, which can be painful.
So it kind of handles some of the orchestration bits for you?
It handles all of the orchestration for you, and you just need to take care of your algorithm, correct?
Nice. What are the kinds of day-to-day things you're doing working on Dask currently?
Chiefly, I work on the stability and performance of the Dask scheduler that handles all of the workflow that runs under the hood that is normally kind of invisible to the user.
Maybe we could get a little background on the project. I'm not sure of how long Dask has been around.
Oh, it's been around for a long time. Definitely more than 10 years plus. Cannot remember exactly.
Okay.
It gathered popularity exponentially over the last few years.
Yeah. I guess with the growth of these tools, has it always kind of been based in Python?
Yes, 100% Python.
Yeah. So the growth of Python and data science has definitely mirrored some of your growth. That's great. Maybe we could talk a little bit about how somebody would get started using it. I was mentioning again before we started how I'm very much a solo developer, and I work for, kind of a training company. And so I don't do as many large data sets and so forth. I do some for training purposes and creating examples for students that want to learn more about data science. But I feel like as an entry point, I wonder how an individual would get used to using it. I think when an organization jumps into it, it can be kind of a different thing. And so if somebody's maybe wanting to learn some of these tools, which is always kind of a focus for me, is helping to kind of provide some skills and some knowledge so somebody who's interested in getting into the industry would be more comfortable around them. And so I kind of wondered how somebody might get introduced to using Dask.
Right. So I assume you're familiar with NumPy and pandas. correct?
Yes, absolutely. Yeah.
Right. So with pandas, you are loading your data from CSV or whatever other format you have on disk or on the network, and you do processing, and then you do output. Now, if you're doing all that right as of today on your laptop, and you're doing that in seconds and without any particular memory issues, you don't need Dask.
Okay.
Just don't use it. Don't bother. You will not get any benefit. However, if you have problems where your data is in the beginning, at the end, or in the middle of the computation, more than your laptop can accommodate
Okay.
in the physical memory, or if it takes many minutes, if not hours, if not weeks, to compute everything,
Yeah.
then you definitely should look at Dask.
Okay. And one of the things as I kind of started to explore the package and learn a little bit about it is that it, in some ways, is I don't want to say replacing, but it is creating versions of pandas data frames and NumPy arrays in its own names and methodologies. And so I kind of wonder, maybe we could talk a little bit about that. Is that required in order for Dask to achieve some of these distributed techniques?
Yes and no. So there are two ways to approach Dask. On one side, we have packages like Dask Data Frame and Dask Array, which aim to replicate the look and feel of pandas and NumPy respectively. And you have on your Jupyter notebook, you have this object which looks like a pandas data frame or a NumPy array. You apply all the methods that you're familiar with, whatever, slice by column, group by, etc. And everything looks the same, except that you are manipulating 20 terabytes of data.
Yeah.
And that is on your laptop, which has 80 gigabytes of RAM. You push button and your computation either runs on your laptop if you have enough memory for that, or it goes remotely to the cloud potentially, or to your local data center, and get runs on 1,000, 2,000, 5,000 CPUs or GPUs as well, and goes back to your laptop. There are also abstractions like Dask Bag, which make the whole workflow look like some very familiar with Spark. We have map reduce parameters. And then we have raw commands where you say, submit this function to the cluster with this input data. The input data is not necessarily on my laptop, maybe already on the cluster, maybe the output of another function, and give me a future of the result. Of future meaning I have this thing that promises that eventually I will get the result if I ask for it. In the meantime, the result is being computed somewhere else on the cloud.
Yeah, I was diving into one of your resources on the Coiled site. The first one was common mistakes to avoid when using Dask, just to kind of get a background on it. That one's by Richard Pelgrim. And then it linked to a Medium article that Richard also wrote that's called The Beginner's Guide to Distributed Computing. And I think it was a good guide to get people in the mindset of distributed computing. The idea that when you're dealing with these massive data sets, it doesn't always make sense to, it's sort of the idea of like delaying computation, which I think is kind of an interesting idea and doesn't really come into play so much like in the laptop scenario, but with, a distributed computing situation, you're not going to want to constantly be pressing all those distributed machines. You want to basically have them do their work for that little amount of time, sort of this fractional computing idea. Am I going the right direction with that?
Yeah.
Okay, cool. And I thought that was kind of neat, and the idea of it. And then the other trick there is kind of the idea that you're able to separate the data up into sort of partitions.
Yeah.
And I'm guessing that's one of the key things that Dask helps with.
That is correct.
Okay.
Well, it's not like it helps you must do it.
Okay.
If you have a pandas data frame, which is a few tens of millions of lines, you don't really have an option not to split it because it will simply not fit in memory all at once.
Okay. And all these individual remote computers have their own little certain amount of RAM themselves. Is that right?
Yeah, you have workers, so-called, that have regular computers on AWS or whatever, that have 4 gig, 8 gig of RAM mounted on them. And the whole thing works because each of them computes only a handful of partitions at the same time.
Right.
And doesn't need to hold the whole thing in memory.
Okay, great. I guess that kind of gets into a little bit of what your talks are about, this idea of, okay, now you have all this data sort of distributed across all these different workers and the management of that in some ways. And I could see how that gets to be kind of crazy. But there are tools built into Dask that kind of look at that, right? The dashboard.
Yeah, the Dask has a dashboard that runs in the browser that shows you what's the flow of your tasks through the cluster. It shows you the memory usage on every worker on the cluster. It shows if there are problems such as a worker that is too saturated with memory and so forth.
Okay. And then that triaging is kind of what some of your talks were about, right?
Yes, in part.
Okay. Are there things that someone looking at getting into doing the distributed, version of data science, like growing into that, can help to avoid? That's kind of why I was looking at like the common mistakes, like trying to think of advice for people. And some of it I thought that was interesting is this shift. And I guess I didn't give you a heads up on this, but there's kind of a shift to using this Parquet format.
Yeah.
Maybe I talked about it briefly on the show, how it can in some ways be a replacement for CSV. And maybe we could talk a little bit about, is that something that you suggest that people do?
I am not particularly involved in the Parquet project, but yes, I hear a lot of buzz about it.
Okay. Yeah, like I don't know, it's looking at some of the advantages of it. And the one thing that reached out to me in this one thing I was reading was CSVs are literally comma separated values, but as a format, a really common thing that people do in early Python is to read a file in, and then they'll read it line by line.
Yeah.
And that makes sense for CSV in the sense that, it is a line of data and so forth with sort of an end of line thing. And Parquet, I guess, is completely different in a sense that it is columnar, that it's not row based, but it's actually column based, which I thought was kind of fascinating. Kind of like, I guess, individual sort of, if you think of them vertically, vertical arrays. And then they say that it's much easier to sort of handle and prune. I guess maybe that has to do partly in the sense that you have the ability to define the type, right, that a particular column is based on, unlike a CSV doesn't include.
I mean, everybody knows CSV. It's very, very basic. The good thing about CSV is that it's anybody with a text editor or Excel can open it up.
Yeah.
The bad thing is that any sophisticated thing you may want to do, like defining the format of your columns, or even this is a date. Is it in the US format or in the European format? Is the month first or the day first? You have no idea.
Right.
So if you look at the code of pandas, you have stupidly complicated algorithms that just try to infer the date format because CSV doesn't offer it on its own.
Yeah, and in the end, you
will get it wrong.
Most typically end up with an object.
Yes.
Which is, kind of a memory issue there. I always think about the idea of such a common thing that the area of data science I was most involved with would be cleaning data. I guess it's kind of become a field of data engineering.
No. The saying that your assumption is to work with clean data is you're setting yourself up to fail. Your data will be dirty, and you need to think about, okay, what kind of ETL processing do I need to make it into an acceptable state? Yeah.
Okay. Yeah. So anyway, I was intrigued by that format being mentioned by quite a few of the resources on the Dask site. I feel like it's kind of a trend to not only provide data about the columns of information, but potentially it's going to be even sizes, and that can help a little bit with the memory management.
Oh yes, CSV is highly inefficient. You don't it's good for humans, but it's really bad for computers, you need to decode the text
Yeah.
at all times. And
Yeah. So maybe we could dive into it a little bit. When you're working with your distributed setup, you talk a little bit about what is managed memory, and maybe you can define that for me.
Right. So let's say that you start a cluster of Dask workers, 10 Dask workers, each of which mounts 8 gigabytes of RAM. Congratulations, you now have 80 gigabytes worth of distributed memory.
Okay.
Now, however, you need to start a Python interpreter 10 times, which if you start importing NumPy and pandas, that's already 200 megabytes per worker that goes away.
Mm.
Then you need to start having some global variables in there, and that adds up. That is the background noise that you really can't avoid. But then you start submitting your problem, your computation to the cluster. And again, you can do that with Dask array or Dask data frame, which are abstractions that look like NumPy and pandas, or you can do it directly with submit. Take this function, take its input data, and give me the output. Now, when you say give me the output, what you're actually saying in 99% of the cases is give the output to the function that comes next, and or store it there for some other reason. Maybe I want to inspect it or want to do something with it. Now, that function's output is what we call managed data, is memory that Dask knows about. So Dask on one side reads the process memory of the worker, sees, 3 gigabytes out of 8 are busy. And then it looks at, okay, of these 3 gigabytes, what data is the worker storing at this moment? And that's a very dynamic thing because the data is discarded as soon as you don't need it anymore.
Okay.
You have intermediate steps and you drop them as fast as possible in order to make the memory pressure lower. But still, you will have some. So the sum of all the data that Dask knows about, that is the output of tasks, of functions, is what we call managed memory. What everything else is what we call unmanaged memory, which is the library load, as I mentioned, global variables, and then maybe you have a C library that leaks memory, or you can have memory fragmentation, or you can have glibc that does its thing with memory management too.
So that unmanaged memory is kind of a side effect that you just can't know exactly what's going on with it per se. If it's like something like a memory leak, it's something that will, definitely grow over time, depending on what's causing it. And then you said the libraries themselves. Is that something that I wonder about that sometimes? Like there's been a lot of efforts to try to make some of these libraries smaller. Even Python itself, that's kind of one of these things with WebAssembly. That's kind of a new thing people are talking about. But in order to fit Python in the browser, you need to kind of scale back a lot of the things that are maybe not needed, maybe remove some of the batteries that are included. Is that something that is happening in the data science world, or is that like they think about that?
It's not really happening because in data science, the unit of measure is always in gigabytes. You don't need to deal with running Python in the browser. We don't need to deal with running it on a Raspberry Pi.
Yeah. Okay.
So when you open your Python interpreter, you say import pandas, and you suddenly find yourself with 150, 200 megabytes of memory. In data science, that's completely negligible.
Yeah. Okay.
Now, what is very important is that once you have that kind of background, it doesn't grow over time because for Dask, for example, you have semi-permanent services that cannot possibly accumulate memory over time because at some point they will die.
So that's what happens. Like if something like that keeps growing in the background on one of these particular workers and it eclipses the amount of memory that's available, what's the experience there? A crash or?
So Dask tries to be resilient as much as possible to this.
Okay.
Once your memory once you start reaching very high memory usage, by default it's 60%, then Dask will automatically start spilling or swapping out, if you prefer, managed memory to the local disk.
Okay. Kind of like the old school concept of quote unquote virtual memory.
Yes, except at this application level. But yes,
okay.
It's essentially virtual memory. So you take a major hit in terms of performance, but you gain extra memory. And that is convenient if you have some parts of memory that are not going to be used anytime soon.
Okay.
We use the usual cookie cutter heuristics there, least recently used, etc. After you get beyond that threshold, so if your memory keeps growing and growing, even after you'll be spilling everything you could to disk, and again, Dask can only spill managed memory, which is what it knows about. It can't tell, I don't know, NumPy to say, hey, park your interiors somewhere else on the disk now. There is no such API, right?
Right, okay.
So after all the managed memory is being spilled and the memory is still growing, you may reach the point where you finish your 8 gigabytes, for example, in the example before. And at that point, the worker will be terminated and restarted.
Okay.
Now, at the moment of speaking, you have a hard termination, meaning that you lose all the data that was on that worker. That doesn't mean automatically that on the client from your laptop you see an error.
Okay.
Because Dask will automatically notice, oh, I just lost a worker. What pieces of data did I have on that? X, Y, and Z. Cool. What is the process to rebuild those from scratch? That. Automatically continue somewhere else on the cluster you don't notice. Yeah, you notice a slowdown. You notice it takes longer than usual, but otherwise it does not crash.
So that's that whole orchestration.
Yes, that is the same logic if the worker runs out of memory, if the worker gets a memory glitch and gets disconnected from the network glitch and is not reachable anymore, if the worker is, I don't know, runs in an infinite loop because you sent it the wrong algorithm and it cannot be contacted anymore, or, I don't know, your motherboard goes on fire. It did happen to me once.
Okay. This week, I want to shine a spotlight on another Real Python video course. It's a new type of video course. Instead of being based on one of our written tutorials, it's a conversation about code. And in this case, it's on a more intermediate topic, how scope works within Python and what a closure is. The video course is titled Exploring Scopes and Closures in Python, and the instructor for this code conversation is previous guest Martin Broyce. He takes you through clarifying code by refactoring with descriptive names, how functions access variables in local and non-local scopes, how inner and outer function calls access scopes, and how to debug a project and its scope using the Thonny editor. You also take a deep dive into the inner workings of Python by inspecting Dunder objects to find out how Python handles and stores variables. Like most of the video courses on Real Python, the course is broken into easily consumable sections. You get code examples for the techniques shown, and all Real Python courses have a transcript, including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the enhanced search tool on realpython.com. Well, that's great. That kind of explains a lot of the kind of inner workings and sort of the recovery methodologies that are kind of built into it. That's nice. One of the things that you mention as a possible thing that can be done is, or I guess in some ways, Python itself, you were talking about how, it has its own footprint. And then as it's working, it has certain objects that are being created and then objects that are no longer needing to be referenced anymore. And so it can do garbage collection. And you were talking about how in the article a little bit about maybe even triggering garbage collection, which I'm not sure if that's a common thing. I guess I'm trying to get an idea of like, what are some of the steps that you might do to help with the footprint? And if there's something that's alerting you to, I'm needing to get more hands-on with my memory management?
So, as a rule of thumb, you shouldn't need to trigger garbage collection by hand.
Okay.
There are some techniques that are available to you if you have memory problems. The first thing that you could totally try, if you see, first of all, open your GUI, and while your computation is running, look at the memory graph and figure out the dashboard. See, is the memory mostly managed memory or is it unmanaged memory?
Okay.
If it's mostly managed memory, the first thing you should try is to enable a new component which is called Active Memory Manager, which I wrote, which will go through all the managed memory on the whole cluster and say, okay, is there anything I can drop? Because it's redundant and this is no longer needed. In part, this is something that happens normally, but the active memory management does a more thorough job of it.
Okay.
If your problem is with unmanaged memory, things get somewhat more complicated because it's hard to figure out where the problem is. If you see that it grows over time, then go for the usual suspects like that one C library that some data scientist wrote 5 years ago, and that's leaking memory for sure.
Okay.
And the other thing that you should consider is what is your partition size or chunk size.
Okay. And that's something that you would adjust depending on the project?
Yes. So partition size is, you have a pandas data frame of 1 billion lines.
Okay.
And you say, I want chunks of 10,000 lines each.
Okay.
And create as many chunks as needed, but they will be all the same 10,000 lines. So that gives me a good idea. I don't actually know the size of the whole data frame necessarily, but I do know that in the individual chunk is, say, 100 megabytes or something like that. So if you reduce the chunk size, then you will have more granular data, and also the heap of your functions while they run will be smaller intuitively.
Okay.
If you have a function that does, I don't know, calculate the age of all the users on that data frame, whatever, then it will run in half the memory if the chunk size is half the size.
That makes sense. Yeah. So like you're reducing the overall output of all the functions that are running and so forth.
Yeah, you're running twice as many functions on half of the data each.
Okay.
On the flip side, if you reduce the chunk size too much, you are also going to incur in a higher overhead, and you will end up with something that is called oversplitting, where your actual good computations are maybe 1 millisecond per function, and that starts being really painful because you end up with most time spent by Dask itself just trying to manage your gargantuan algorithm.
Okay. This is sort of a latency introduced by it having to manage all of them and keep track of all the things and make sure that they can continue to run in parallel.
Yes. So you need to tweak the partition size depending on your problem.
Okay. I wonder about a lot of these techniques and skills that a data scientist would learn as they kind of do this. Is this something that you just sort of learn as you go? Like it's sort of its own form of experimentation?
I believe that the Dask tutorials that are around do say, hey, chunk size is a thing. This is how to figure out a good chunk size for your problems. And chunk size is the first thing you need to learn. Everything else comes later, and most people hopefully will not hit it.
Okay. Were there other things that you were getting into with your work that would help somebody in this idea of like, managing their memory and so forth that we didn't touch on? Like I mentioned garbage collection, but there's this thing in there called memory trimming.
Yes, memory trimming is a very low level thing that the glibc does.
Okay.
So you know how you studied in high school that or in uni that C doesn't have garbage collection and doesn't have, and every call to malloc goes directly to the kernel. Whereas Java, you invoke the equivalent allocation function and it goes to a user space, and then eventually it goes to a pool, and then it goes to the kernel, and then there is garbage collection on top of that.
Okay.
Actually, C does the same as Java nowadays, but most people don't know about it. So whenever you do malloc in C, you're not hitting the kernel one-to-one. You're going to the glibc, which runs in user space, which in turn says, okay, do I have a free pool of memory that is there from the last time I freed something and I didn't release it to the kernel? If yes, use that. Otherwise, go to the kernel and ask for malloc to the kernel. Same for free. I'm freeing some memory and say, oh, yes, this may be useful later. So don't release it on the kernel and keep it there on the process, which is great if you're doing a lot of C, C++, malloc, and free. It's bad if you have something like Python, which has its own memory management.
So you're kind of dealing with...
Python does the exact same thing on top, which can get painful.
Is this where you were talking about some C extension libraries and so forth could be running into memory issues?
Well, C libraries can leak memory because it's C. If there is no garbage collection at user level, so if you do malloc and then you forget to free, that stays there forever.
Yeah.
Unlike in Python, you descope something and it's gone. PyFree will know that you can release it and potentially release it to the OS. But yes, these techniques that there's this malloc memory pooling that the glibc does is specifically for C, C++ libraries. It's not very useful for Python.
Okay.
Particularly not very useful when the bulk of your work is NumPy arrays that are tens of megabytes each.
Okay. Yeah. I kind of reached out to the community to find some questions, and I just thought this might be kind of appropriate. It's really specific in the sense, but Suman Das asked, what is the data size Dask SQL can handle? And I would imagine, it's totally up to you as far as the distribution of project. Is there an upper limit?
I'm not familiar with Dask SQL myself.
Okay.
At the moment, we are scaling to we are pushing the limit of terabyte size.
Okay.
Terabyte scale of data.
Yeah, that's what I was thinking.
It's a hard limit. It's still a bit of a bumpy ride, but we are working hard on that to say, yeah, a terabyte, 5 terabytes, you can do it, no problem. At the moment, you may find yourself Dask starts choking a little bit, but it's a work in progress, rapidly improving.
Okay.
For as long as you are in the tens of gigabytes or even hundreds of gigabytes, you're good.
What are some examples of projects that are out there using Dask right now?
Many projects are using Dask. It's very cross-industry because it's used by anybody who needs to deal with giant data sets, that pandas-like data sets.
Yeah.
It's heavily used in finance when they need to run Monte Carlo simulations of millions and millions of scenarios. I was previously employed in insurance where I was running daily on 200 gigabytes worth of data, and I had to produce reports on that, which would take 2,000 CPU hours to produce. And I was churning those 2,000 CPU hours in 3 human hours.
Okay. So you can kind of imagine the distribution with that.
Yes, exactly.
Cool.
It's used in all kinds of scientific fields like geosciences, meteorology, and whatnot. You name it. It's turbulence analysis, you name it.
And it's not picky as far as where it can distribute the work to, right? Like as far as the background services, it could be using AWS or Google or what have you, right?
Yes, it runs on Linux, Mac, or Windows, and you can start a worker wherever you want. But notably, you can start a worker on a machine that, for example, mounts NVIDIA Tesla graphic card.
Nice. I thought about asking about profilers and other tools. Are there things that I'm missing? But it sounds like mostly it's done with the Dask dashboard.
It's done well. You do it with a dashboard. On top of that, we have tools that allow you to monitor memory usage over time. They are in the documentation. And whenever you see a bunch of unmanaged memory on the worker that is unexplained, you can send your own an arbitrary function to run instantly on that worker. And at that point, it's like running locally.
Okay.
Besides the fact that you don't have a terminal, but beyond that, you run a function and you want to use, I don't know, what your tool of choice, you can just do it.
Okay. I have these weekly questions I'd like to ask everybody, and I wanted to know, what are you excited about in the world of Python right now?
I am really looking forward multiple interpreters, which is a PEP that is currently in development. And for those that don't know, is about running multiple threads of Python, which we all know and hate because of the GIL.
Right.
So Python threads are great because you share memory, and they're exceptionally bad because most stuff will not run well in threads because they all contend for the GIL. Multiple interpreters is somewhere halfway through into threads and multiprocessing, where you have threads at OS level, but they kind of look like processes inside Python, and they do not contend with the GIL. Data sharing is technically not possible, except that you can fiddle with it. You can pass NumPy buffers, for example, so that you don't need to transfer the whole thing. You have a 100 megabytes NumPy array. You just need to transfer the metadata for it, and everything else you just run on a view. And when that comes out in CPython, Dask will jump on it heavily because it's groundbreaking.
Okay. Yeah. Is that still kind of in work in progress? I haven't kept on it. I talked about it maybe a year ago.
It's heavily work in progress. I don't know if there is a deadline for it. Also, don't know if the key feature, which is GIL separation, is in 3.11, even if the whole thing goes out.
Okay.
It's enough to start playing with it, but if it doesn't release the GIL, then there is no point.
Yeah. Okay. It should be interesting. There's so much kind of cool stuff happening under the hood in the CPython development work, and then lots of great companies kind of helping to fund some of that too, which is really awesome. So yeah, I'm looking forward to the next couple of years here. So what is something that you want to learn next? It doesn't have to be Python specific.
Well, I am playing around a lot with CUDA. It's really fascinating, particularly how it can work inside Python for small bits, just that needs to be accelerated. It works very well inside Dask, by the way. I am also studying Rust.
Okay.
For, well, fairly obvious reasons.
Is Rust something that you guys use in development and for the tools for Dask?
We do not. There was a conscious decision of keeping to pure Python to let the community contributions go through unimpeded.
Okay. Yeah, that's a really common answer for that question. People wanting to learn more about it. Are there other specific things that you're looking to get out of when learning Rust?
In general, I want to see how Rust can optimize critical parts of Python. I'm not very interested in writing large-scale applications in pure Rust, personally. I like the idea that Python can deal with a lot of your boilerplates so fast.
Yeah.
And then you just need to rewrite that tiny little bit in a faster language.
Yeah, that seems to be a trend too, right? The idea of quick development, get things going, stand it up on its feet, and then optimize and maybe bring in other languages for help with that. What are ways that people can learn more about the things that you do online?
Dask.org is beginning of the trip there, and they should also visit the Coiled.io website.
Okay.
For if they want to scale Dask in minutes.
Are there any other talks or conferences you're going to soon?
I will be at PyData London in, I believe, June. I'm not sure if I will be presenting there. I haven't been. I forwarded a proposal, but I didn't get an answer yet.
Okay. How often do you go out and do talks? I'm guessing it's ramping up, but were you doing lots of virtual ones over the last couple of years?
I did a couple.
Okay. They're hard, aren't they?
Virtual ones are horrible. You don't even know how many people you are in the room.
Right. You got no idea of the energy level and reaction, and yeah.
When I went back to physical talks, it was oh, this is what it was. Now I remember. Yes, different thing.
Yeah, totally. Well, Guido, thanks so much for coming on the show and sharing everything with us.
Thanks to you.
I want to thank Guido for coming on the show this week and talking to me about Dask. Next up, I'm going to introduce you to Jodie and our plans for covering more data science topics in the future. Hey, Jodie, it's so great to talk to you again after PyCon. I wanted to not only have you come on the show and just briefly introduce yourself, but introduce you to the audience and the ideas that we have of trying to talk about more data science topics by bringing in somebody who has worked in that field a little more. And so I thought we could just do a bit of an introduction. And so, Jodie, tell us a little bit about yourself.
Yeah, so thanks so much for having me on the show, Chris. Also was a pleasure to meet you at PyCon. So yeah, to give everyone a little bit of an orientation about my background, I trained academically actually as a psychologist, and then I worked a little bit in biostatistics. Following that, I decided to escape academia, and I've been working for about 6 years in industry as a data scientist, different fields, mostly concentrating on job boards and programmatic advertising. And I recently started at JetBrains as their developer advocate in data science.
Yeah, and that's kind of how we met. That was fun.
Mm-hmm.
Dan and Paul had met and talked and said, hey, these two people should meet. And then it was so funny because we sat down at a table and they both like peeled off within like 3 or 4 minutes of us starting to talk. They're like, okay, these two are going to do well famously here.
So yeah. And then I think we sat there for another half an hour, right?
At least, yeah.
Then we're like, oh, we should probably get back to the booth.
Yeah, that was fun. Yeah, so I'm very excited. I have a whole bunch of guests lined up over the next months in the summer here, but you said that your schedule is going to maybe be opening up in near the end of the summer.
Mm-hmm.
And so hoping to just get people excited about, hey, this idea that, hey, we're going to have more data science topics,
mm-hmm.
have someone who I can kind of bounce my questions off of because again, I don't do as much with it. I worked in marketing. And so I did quite a bit with Jupyter and pandas, and I know the tools and did a little bit of modeling, very, very minimal amount. Mostly was working with other people that were doing that. I was kind of more, my role was considered an automation engineer. And so I was kind of building more like tools that other people could use, which is fun. And I really like that kind of part of the problem solving. But I was super interested in all this sort of stuff. So you had a couple ideas of potential topics. We already kind of bounced around the idea of talking about maybe some of the ethics behind machine learning. And what were some of the other ideas that you had that maybe we could kind of tease them a little bit here?
Yeah, so quite a lot of my career I worked in NLP, and I came into NLP with really no knowledge. So I had to learn everything from the ground up. So something I thought could be very interesting to explain to everyone is how you take a bunch of text documents and you convert them into something that you can use for machine learning. And the process is actually, it really mirrors the way that we as humans digest documents. We just need to teach the models to incorporate more and more of that information that we internally process. And then something else, this was really core to my study as a psychologist, but it's really learning how to assess whether your data set is any good for modeling.
Okay.
Potential pitfalls and tools you can use in Python for teasing out that information.
Okay, to see if there truly is a signal within the noise of all this data that you have.
Yeah. And like just when things are going wrong with your model, you can, examine all the like fancy confusion matrices or metrics that you like. But sometimes it's just that your variables are kind of screwed up and you need to know how to look out for that. So just some tricks for screening for those.
Yeah, that sounds fantastic. Yeah, and then I thought maybe one of the other avenues we could take is do a little bit of what I'm doing with Christopher Trudeau of what's happening maybe news-wise or article-wise in the world of data science and machine learning and all that sort of stuff, and have somebody to help me kind of not only navigate it, but translate some of it. So I'll probably be asking you to like, okay, what do the letters NLP stand for? And, all that kind of stuff, so that'll be fun. Yeah. So like I said, I just wanted to kind of do a quick introduction, get people kind of excited about the idea. I guess if you do have burning questions here in the audience, please send them to us. You can send them by email. I've been getting a bunch of ideas for guests and topics lately, and I really enjoy that. And I'm trying to do my best with that. Thanks, Jodie, for coming on and talking to me.
Yeah, of course.
All right. Well, we'll talk soon.
Okay. Looking forward to it.
I want to thank Guido Imperiale for coming on the show this week. And I want to thank Jodie Burchell for providing that short introduction. And I want to thank you for listening to the Real Python podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and I look forward to talking to you soon.